All right, in one of our labs we dealt with ticker tapes where we had a spark timer, and the spark would put burn marks every so amount of time on a piece of paper. And if you take the paper and you pull the paper through faster, then the sparks will be farther apart. Or if you pull it through slower, the sparks will be closer together. But the amount of time between one dot and the next dot would always be the same amount of time. There might be more paper between the two dots, which means it has traveled a further distance, but the amount of time between two dots would always be the same. So the first thing we always try to do is find the period of the timer. We tried to figure out how much time is between two dots. And we're going to say that the time between two dots for this one is 1 second. We'll make it nice and easy, 1 second. So if you look at this particular piece of paper, this ticker tape, you'd ask yourself the question, what kind of motion was happening here? This was attached to some vehicle or whatever, and what was the vehicle doing? And you would say that this vehicle was going at a constant velocity, a constant v. How do we know that? Well, the dots are evenly spaced all the way throughout. So there's the same amount of paper or same amount of distance between each dot. And we know that the time between each dot is the same amount of time, 1 second. So if we look here and we count how many intervals we had, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 intervals. That would mean 12 seconds worth of time. And you see down here that we measured from the first dot to the last dot, and that was 24 centimeters. So 24 centimeters divided by 12 seconds means that this car was traveling at 2 centimeters per second. You could figure that out. You could figure out a velocity by knowing how much distance it went and what the period of the timer was. Let's look at another ticker tape and try to figure out what happened here. Well, in this one, you'll notice that they start out really close over here on the left side. They start out really close, and then this thing starts moving, and there's a little space between it, and there's a little bit more, and there's a little bit more, a little bit more, a little bit more. Now, what does that mean? Does that mean there's more time between these two dots than there is between this? No. We know the period was, in our example, was 1 second. So there's the same amount of time between one dot and the next dot. But you'll see there's much more distance here. What does that mean? It means it's going however many centimeters this is divided by 1 second fast. So let's say there's 5 centimeters there. So between here and here, it's going an average velocity of 5 over 1, 5 centimeters per second. What if there's only 3 centimeters between these two? Well, between this is going an average velocity of 3 centimeters per second. Maybe between these two, it's only 2 centimeters per that 1 second. So what's happening in this car? This car is doing what we call acceleration. Accelerating. Did I spell that right? Accelerating. It's going faster and faster and faster is what this car is doing. Let's look at a third and final one. Try to interpret what happened here. At the beginning over here, we see the car looks like it's starting out. And there's a little bit of space, there's a little bit more space, a little bit more space, a little bit more space, a little bit more space. So from here up into right here, it looks like this car is speeding up. It is accelerating. But then if you look between here and here, and between here and here, and between here and here, it looks almost like this same amount of distance. So maybe our accelerator may went a little too far. Maybe somewhere right in here. Somewhere right in here, we start kind of going at what we'd say a constant velocity, a constant v. But then you'll notice that it's a smaller distance and a smaller distance and a smaller distance. So from here to here, we are slowing down or decelerating. And then it looks like right here, that we're probably stopped for a while. There's a whole bunch of dots kind of right there in place. So we're probably stopped there. And then what happens? Well, a little bit more, a little bit more, a little bit more. We're accelerating again. So a lot of motion can be determined by examining a ticker tape. We're accelerating, going faster and faster and faster, and then nice constant velocity, and then we started slowing down and were stopped. And then we started accelerating again. And that's what we can figure out from ticker tapes.